So you probably have an optical or HDMI cable hooked into the back of your TV setup right now, right? And it likely cost you, like, what, maybe 15 bucks?
Yeah, maybe 20 if you splurged.
Right,
Yeah.
exactly. So why does HDTVSupply have this seemingly identical black plastic cord listed for $485?
It is a massive price jump, yeah.
It really is. So today we are doing a deep dive into the DVIGear DVI-2340-FOD. It's this 40-meter or about 131-foot fiber optic cable. And our mission here is to decode these specs, to really understand this highly engineered, invisible infrastructure that actually powers professional tech.
Because when you look at this product page, you immediately realize you are paying for the absolute backbone of commercial data communication.
It's not just a basic cord.
Exactly, no. It is an incredibly precise optical instrument, honestly, just disguised as a boring black cable.
Okay, well, let's unpack this. Looking at the core specs, the page highlights a 50/125 micrometer multimode fiber alongside 8 precision-terminated LC connectors.
Right, those are the key numbers here.
Yeah, and I want to look closely at that multimode spec because for a cable this expensive, why are they using multimode instead of, say, single-mode fiber? Is that just overkill?
Well, no, it comes down to the specific job this cable has to perform in these commercial setups. Think data centers or broadcast facilities.
Okay.
So the 50/125 refers to the actual physical dimensions of the microscopic glass inside. The core itself is 50 microns wide.
Which is tiny.
Oh, incredibly small. And it's surrounded by a 125 micron cladding that essentially acts as a boundary mirror. But because that 50 micron core is relatively wide for fiber, it is multimode.
Meaning multiple beams of light?
Exactly. Multiple beams or modes of light can travel through it simultaneously.
That actually makes perfect sense when you visualize it. I mean, it's like a wide hallway, right? If you have a massive crowd of data trying to get through, they can rush down the hall together, kind of bouncing off the walls at different angles.
That is a great analogy, yeah.
Whereas single mode is more like a tightrope. Like the data travels in a strict single file line straight down the middle. So multimode gives you that massive simultaneous bandwidth over a shorter commercial run.
Spot on. And when you combine that wide hallway with those 8 precision LC connectors, you get an incredibly dense, low-loss optical transmission.
Right, an 8-lane data superhighway basically.
Exactly. And broadcast environments, they are pushing uncompressed, mission-critical audio and video.
There's a lot of data moving at once.
A huge amount. And in those spaces, latency or a dropped frame isn't just an annoyance like it is at home.
Right, your Netflix buffering is one thing, but here,
it is a catastrophic failure in a broadcast. The hardware absolutely has to guarantee that the data arrives instantly.
So we have this massive volume of mission-critical light firing through these glass fibers. But a cable like this isn't just sitting exposed behind a living room desk.
No, definitely not.
It's being dragged through the walls and ceilings of massive commercial buildings.
Yeah.
And that completely changes the physical demands placed on it.
It absolutely does.
Which brings us to a spec that is taking up a surprising amount of real estate on the product page. The CMP Plenum-rated black jacket. Now, I have to push back a bit here on paying a premium for a plastic casing.
I know it sounds crazy.
It does. If it's going into a ceiling, like completely out of sight, shouldn't the jacket be the absolute cheapest part of the cable? Why brag about the outer layer? What does plenum actually mean in the real world?
Well, because the chemical makeup of that outer layer is quite literally a matter of life and death in a commercial environment.
Wait, seriously?
Yeah, we know Plenum ratings deal with a building's air handling spaces. Think about the drop ceilings or raised floors where HVAC systems push the air around.
Okay, yeah. The spaces above the office tiles.
Right. What gets overlooked there is the stringent fire code reality. See, a cheap PVC jacket on a standard home cable acts as highly combustible fuel if a fire breaks out in a server room.
Oh, wow. And because that cable is sitting in the plenum space, I guess any toxic fumes and thick black smoke would get sucked straight into the building's ventilation.
And pumped into every other room.
Right. It would just spread instantly.
Exactly, which would rapidly poison the air supply of the entire facility. So a CMP-rated jacket uses specialized fire-retardant plastics.
So it's not just basic rubber.
No, they're often complex fluoropolymers, like Teflon, actually. They are engineered to self-extinguish and emit virtually zero smoke.
That is wild.
Yeah, the rating dictates strict chemical engineering just to ensure this vital piece of networking gear never compromises a building's fire safety or indoor air quality.
So it looks like a standard boring black cable is actually a high-speed fire-retardant optical lifeline. I mean, it really shifts your perspective on what's hiding directly above our heads.
It does. We tend to think of infrastructure as just the concrete and steel of a building.
Right.
But there's this entire secondary architecture of precision technology and strict safety standards layered right on top of it.
It definitely reminds you that our seamless digital experiences, the ones we completely take for granted, are held together by expensive, highly regulated physical tethers hidden right out of sight.
Hidden away in the ceilings.
Yeah.
Yeah.
So we'll leave you with this final thought to ponder. In an era where we constantly celebrate our shift to a completely wireless world, how deeply are we actually still tethered to miles of hidden physical optical fibers?